Have you ever stopped to wonder just how solid the world around you really is? Maybe you're lying under a warm blanket right now, and your bed feels firm, the walls seem utterly reliable. But what if I told you that this stability is an illusion? What if reality itself, the very space we exist in, is actually shimmering, like the surface of tea in a cup sitting on a moving train table? Scientists recently confirmed what Albert Einstein only suspected. They've detected a permanent, pervasive background hum throughout the cosmos. This isn't just sound, it is the ripple of the very fabric of existence. Today we're going to take an incredibly calm and slow journey to the source of this cosmic drone. We will explore why space seems to breathe and how distant black holes are lulling our galaxy to sleep with their colossal gravitational dance. Settle in. Close your eyes. Let's listen to the silence that is, in fact, not silent at all. To truly grasp what we're discussing, we need to rewind time a bit. Think back to your high school physics class. We were often taught that space was just a stage, an empty black box where stars and planets happened to hang out. Isaac Newton believed exactly that. For him, space was absolute and utterly motionless. But then Albert Einstein arrived and turned the entire concept on its head. He suggested we stop viewing the universe as an empty container, but rather as a fabric. Imagine a tightly stretched sheet. If you place a heavy bowling ball in the center, the sheet sags. If you then roll a smaller marble nearby, it rolls toward the large ball, not because of some magnetic attraction, but because of the curvature of that fabric. That, fundamentally, is gravity. Einstein realized that massive objects literally warp space and time. But the real breakthrough came later. Scientists wondered, if this fabric can bend, can it also vibrate? Can ripples travel across it like circles on the surface of water after a stone is thrown? The answer was yes. And now, a century later, we have finally learned to hear those ripples. Let's begin with a simple image. Picture a tranquil lake early in the morning. The water is perfectly smooth, like glass. This represents our space in a state of complete rest. Now imagine someone throwing a stone into the water far across the lake on the opposite shore. You didn't see the impact, you didn't hear the splash, but after a while, tiny, almost imperceptible ripples reach your location. They gently rock the lily pad right by your feet. In the universe, space-time plays the role of the water, and the role of the stones is taken by the heaviest objects imaginable, black holes and neutron stars. When they move, they aren't just hurtling through the void, they perturb it. They create waves that radiate outward in all directions at the speed of light. And these waves pass right through everything, through stars, through planets, through your very home, and even through you right now. This is the amazing thought to carry with you tonight. You are not separate from the cosmos. You are quite literally swaying on its waves. But how exactly did scientists manage to detect this? After all, we certainly don't feel ourselves being stretched or compressed. The thing is, these ripples are incredibly tiny. Imagine we want to measure the distance to the nearest star, Proxima Centauri. That's 4 light-years away. A gravitational wave would change that colossal distance by less than the width of a human hair. That seems utterly impossible to measure. Yet in 2015, something miraculous happened. The LIGO Observatory detected such a signal for the very first time. It was a burst, short and sharp, like someone hit a drum just once, bam, and then silence. This was the result of 2 black holes colliding. By cosmic standards, this was a monumental event. Scientists were ecstatic. For the first time, we had heard the cosmos. But this was just a solitary cry in the night. Astrophysicists knew that somewhere out there must be more than just that single shriek. There had to be a constant background, a whisper that never ends. Let's try to visualize the difference between that first signal and what we've discovered now. Imagine you're standing in a completely quiet room, and suddenly a vase drops. Smash! That sudden, loud, isolated event is what we captured back in 2015, the collision of stellar mass black holes. But the universe is massive. It holds billions of galaxies, and at the core of almost every single one sits a supermassive black hole. These are millions, even billions, of times heavier than our Sun. When galaxies merge, these cosmic monsters begin circling one another. They don't crash instantly. Instead, they perform a slow, majestic waltz that lasts for millions of years. And as they circle, they are constantly, every single second, emitting gravitational waves. Because there are millions of these binary pairs throughout the universe, their waves overlap and merge. The result isn't the sharp crack of a single impact, but rather a continuous low-frequency hum. It's like the chatter in a busy restaurant, where countless conversations blend together into a unified background noise. This background hum is known as the stochastic gravitational wave background. That's a complicated name, but the concept is simple. It is the voice of the entire universe all at once. To hear it, standard detectors here on Earth simply won't work. They are far too small. The wavelengths created by these gigantic black holes can be light years long. To catch a wave like that, we would need a detector the size of a galaxy. Sounds like science fiction, right? Building an instrument the size of the Milky Way, but astronomers are nothing if not resourceful. They realized they didn't need to build anything at all. The universe had already built the perfect detector for us. We just needed to learn how to use it. That detector turned out to be pulsars. These are incredible stars, and they are worth talking about separately, perhaps while you get nice and cozy under your blanket. Pulsars are the cosmic remnants of long-dead stars. When a massive star explodes, its core collapses down to an almost unimaginable density. Imagine taking our Sun and compressing it down to the size of a small city, say New York or Moscow. The matter inside is so dense that a single teaspoon of pulsar material would weigh billions of tons. But their most important characteristic isn't their weight, it's the fact that they spin. And they do it at a terrifying speed. Some spin hundreds of times every single second. Pulsars have incredibly strong magnetic fields that beam out focused jets of radio waves, and because the star is rotating, this beam sweeps across the Earth, just like the light of a lighthouse. We see a flash, a flash, a flash. These flashes occur with unbelievable precision. Pulsars are truly the most accurate clocks in the entire universe. They are more precise than our best atomic clocks right here on Earth. And this is where the magic happens. Scientists chose several dozen of these pulsars spread out across our Milky Way. They essentially turned our entire galaxy into a massive antenna. The idea was straightforward. If the space between us and the pulsar is calm, the signals from the beacon should arrive right on schedule. Tick-tock, tick-tock. A perfect, predictable rhythm. But if a gravitational wave travels through the galaxy, it distorts the fabric of space itself. It stretches the space, then squeezes it, and that means the distance between Earth and the pulsar also shifts, even if only by a tiny amount. If the space stretches, the signal needs more time to reach us. It arrives slightly late. If it contracts, the signal arrives slightly early. Scientists from the NANOGrav project monitored these stars for over 15 years. Just imagine that patience. 15 years spent watching those blinking dots. The work was painstaking. They had to filter out all the noise. That meant the interference from Earth's atmosphere, the subtle movement of the planets, and the cosmic dust scattered throughout space. Any of it could throw their precise timing off. But once the data was finally clean, they saw something truly stunning. The timing of pulsars scattered across the entire sky was being delayed and advanced in unison. This wasn't just a random error with one pulsar clock. It looked as if the very fabric of spacetime, the stage on which these stellar clocks operate, was rippling. Imagine you're floating on an inflatable raft in a pool with friends. Your eyes are closed, but you feel a wave lift one friend, then move on to lift you, and then the friend next to you. You understand a wave just passed, even though you never saw it. In precisely the same way, these astronomers realized that giant waves of spacetime were washing over the Milky Way galaxy. These oscillations are incredibly low in frequency. A single wave can take years, even decades, to pass completely through us. That is why observing them required such immense stretches of time. This isn't the quick screech of a violin. It's a profound, deep bass note resonating at the very threshold of eternity. Scientists call this the music of the spheres, but it sounds far more like the deep hum of the ocean. And this rumble tells us one crucial thing. The universe is saturated with motion. It is not static, it is not frozen. Even the seemingly emptiest corners of the cosmos participate in this cosmic dance. Right now, as you listen to this voice, the crest of a gravitational wave, born billions of years before the Earth even existed, is passing straight through your room. But what exactly generates this powerful background? The prevailing theory points to pairs of supermassive black holes. When two galaxies merge, their cores eventually locate and orbit each other. Picture two heavyweights locked arm in arm, spinning around. Their combined mass is so immense that they literally churn up the spacetime surrounding them, the way a powerful mixer whips cream. The universe is filled with countless pairs like this. Each binary system sends out its own ripple, and all those individual signals merge into one unified chorus. We aren't hearing a single source, we are hearing all of them simultaneously. It's exactly like standing on the seashore. You hear the deep rumble of the tide. You can't make out the sound of every individual droplet of water, but you perceive the powerful, collective roar of the ocean. This gravitational background is, in essence, the breathing of the cosmos itself. This discovery fundamentally changes how we view reality. Before this, we saw the cosmos as something remote, believing the stars were out there and we were isolated down here. But gravitational waves prove that everything is interconnected. Space itself is a single, unified medium. What happens in a distant galaxy literally and physically affects us. Yes, the influence is infinitesimal. It's certainly not going to knock the coffee cup off your desk. But at a fundamental level, it momentarily alters the very geometry of your body. In one instant, you become a billionth of a nanometer taller and narrower, and in the next, you are shorter and wider. We are all constantly pulsating in rhythm with the universe, and that is a remarkably comforting thought. We are not isolated beings. We are undeniably part of a single cosmic process. There are other theories about the origin of this hum, some even more exotic. Some physicists believe that part of this noise could actually be an echo of the Big Bang itself. Imagine the very first moment the universe was born, a moment of unbelievable energy and chaos. That event might have left an imprint on the fabric of reality, an acoustic remnant that is still traveling through the cosmos today. If this is true, then by listening to this cosmic hum, we are literally hearing the moment the universe was created. It's like deep time archaeology, only instead of digging up dinosaur bones, we're excavating vibrations that are 13.8 billion years old. While we can't yet accurately separate the Big Bang echo from the noise made by black holes, the sheer possibility of doing so is absolutely captivating. Let's get back to that feeling of peace. Consider just how smoothly this all unfolds. Gravitational waves aren't the destructive force of a tsunami. They are a gentle, soft, rocking motion. Scientists often compare them to a subtle ripple. If the universe were completely silent and motionless, it would actually be a little unsettling, like the dead quiet inside an abandoned house. But the presence of this background hum is a clear sign of life. It tells us that processes are ongoing, that galactic evolution continues, stars are being born and then die, black holes merge, and matter is constantly in motion. This steady rumble is the ultimate evidence of the activity and energy that permeates all existence. It's fascinating that scientists had to collaborate globally just to detect this effect. Radio telescopes across the US, Europe, India, China, and Australia all worked in perfect synchrony. This itself was a global network, a massive human detector. People from different cultures and languages listened to the sky together, and they heard the exact same thing. Reality isn't static, it fluctuates. The word fluctuation is incredibly apt here. It means a slight, random deviation. It's as if the universe is subtly breathing, inhale and exhale, expansion and contraction. This rhythm is far slower than our own breath, but it is just as natural. Imagine the very structure of space-time at the micro level. What if we started zooming in, like looking through a microscope? First, we'd see atoms, then the nuclei, then elementary particles. But if we go even deeper, down to where the Planck length reigns, the smallest possible size in the universe, physicists theorize that space itself is churning there. They call this quantum foam. At that level, space and time are constantly tearing and stitching themselves back together, with microscopic wormholes appearing and vanishing in an instant. It's a bubbling, boiling soup of reality. And gravitational waves, that low, cosmic hum we detect, are the macroscopic manifestation of this incredibly complex, turbulent, fundamental nature of our world. Most people look at black holes with genuine fear. They imagine them as cosmic monsters, devouring everything in their path. But in the context of our story, black holes are actually the creators, not destroyers, but generators of waves. Without them, the universe would be a much quieter, duller place. Their gravity is so immense that it simply doesn't allow space to stagnate. They churn the cosmos. You could say that black holes are the engines that maintain the dynamic pace of this great cosmic symphony. And we, here on Earth, are the front-row listeners of this magnificent performance. As you lie here in the darkness, try to visualize these waves. Don't picture them as frightening lines on a graph, but rather as soft, shifting colors. Imagine the space around you shimmering like the northern lights, only completely invisible. Slow, smooth washes of deep purple and indigo. They pass right through the walls, through the ceiling, down toward the Earth's core, and out into space on the other side of the planet. Nothing can stop them, and nothing can hold them back. They are utterly free. And in that freedom there is something profoundly tranquil. The problems of the day seem so small compared to the breathing of the galaxies. Scientists say we are standing on the brink of a new era in astronomy. Previously, we could only see the universe, whether with our own eyes or through telescopes. Now we've begun to hear it. It's like watching a silent movie your entire life, only for the theater to suddenly turn on the sound. The picture of the cosmos is becoming three-dimensional and complete. We will uncover secrets that have long been hidden in the darkness. We will finally be able to understand how galaxies formed at the dawn of time. We can test theories that were once considered impossible to prove. The future promises to be incredibly exciting. But right now, in this precise moment, what truly matters is the sheer wonder of being a part of it all. But there's a philosophical angle to this finding as well. It's a powerful reminder that stability is entirely relative. Even emptiness is not truly empty. Even stillness is brimming with motion. But this shouldn't be cause for alarm. Quite the opposite. It suggests the world is fluid, pliable. It's not a fixed, rigid stone. It's a living current. And we are floating along in this very current. Our consciousness, our dreams, they are all part of this reality too. If reality itself is wavering, perhaps our dreams are simply our way of tuning into these cosmic rhythms. Who knows? Science can't give us the answer yet. But before you drift off to sleep, it doesn't hurt to allow yourself a little room for fantasy. This video is coming to an end soon, and only your own rhythm will remain. The rhythm of your breath. Inhale and exhale. The rhythm of your heart. Try to synchronize them with the imagined beat of the universe. Slowly, calmly. Imagine that every exhale is a small gravitational wave rippling out into the world, bringing peace. You are safe, you are home. And your home is not just a structure of bricks and mortar. Your home is the vast, breathing, singing universe itself, gently holding you within its gravitational palms. Let go of any lingering thoughts. Allow them to dissolve, like ripples disappearing from the water when the breeze fades away. Only stillness remains, only the deep background, the soft, encompassing hum of silence. You are a part of something infinitely vast and beautiful. And that something is now watching over your sleep. Allow yourself to sink into this soft fabric of reality. It holds you. It gently cradles you. Good night. We've traveled a tremendous distance, from the quiet of our own bedrooms all the way to the edges of the observable universe and back again. We've learned that reality isn't a solid, fixed stage, but rather a vibrant, living ocean, humming with vibrations and the secret songs sung by supermassive black holes. The discovery of the gravitational background is a genuine watershed moment in human history. A moment when we finally started to hear the soft whispers of the cosmos itself. From now on, every time you close your eyes, remember this. The apparent silence around you is absolutely filled with cosmic grandeur. Thank you so much for spending this time with me. I truly hope this session helped you relax and feel a profound connection to the wider universe. If you enjoyed this journey, please subscribe to the channel, give us a like, and if you're still awake, let me know in the comments. Do you feel a little cozier knowing that the entire universe behaves like an ocean? Sweet dreams.